Hello everyone, and welcome to another episode of the Func Prog podcast with me, Christopher, and today I have with me Almir Mesic, who is going to talk about, well, a bunch of different things, I guess, but primarily F# and functional programming, and maybe a little bit of domain-driven design as well. So, welcome to the podcast, Almir.
Thank you.
Thank you. And first, could you give the audience a short introduction? Like, what's your story?
Yeah, Almir Mesic. I'm from Norway. Currently living in Bergen. Lived in Oslo the past 10 years, but moved to Bergen. To almost 2 years now. So currently I work at a company called Ren, and we do F#, which is quite nice. I started off my journey, I guess, in 2013. Did C# for 7 or 8 years, I think. Worked primarily as a consultant, but then, as a consultant. And then when I was working on a project at NRK, the BBC equivalent in Norway, I discovered F# and... there's no way looking back after that.
No turning back. Okay,
yeah,
so
exactly.
was your time at NRK, was that like how you discovered F#?
Yeah, so it started off by I did C#, but then I noticed some teams started using F#, and I was quite reluctant and skeptical actually to F#.
Sure.
Yeah, that's weird coming from me. And I was thinking like, why do we need a new language? I mean, C# is a very nice language. It's the .NET framework. It works flawlessly. But I don't know. I was thinking like, in order to have a proper opinion about something, you need to first learn it properly.
Yeah,
so
that makes sense.
So I just sat down with a colleague and I was like, teach me as if I'm a 3-year-old. So let's go. And then I just sat down with my colleague and then, just started writing some simple F# code. And then my mind just got blown away quite fast, actually.
So he was like your Yoda.
Yeah, exactly. And I don't know, what kind of also drew me into it is like, I noticed they had this energy, passion, love for this language, right? And it kind of makes you question like, I want to be, or it makes you think like you want to be part of that as well, right? Like you want to love.
Yeah, it's interesting that you say that, because I've sometimes you see people having like almost the complete opposite reaction. Like they see something that's different and they see people who are really into it, but their reaction is more like that is wrong and those people are weird.
Well, I mean, that's I guess one way to look at it. But what kind of made the the breaking point for me was, I was like, okay, all the great developers I know, really intelligent people, kind, all that. They all say that this language is excellent. So statistically, like, what is the probability that they are wrong and I'm right? So I was like, I have to be wrong, right? So, and then the journey just started after that. And one thing I noticed, like when you start from scratch, you want to learn something, or I mean, in this case, learn F#. People are so kind, like they want to help you learn the language. There's nothing, you don't have this kind of imbalance of, them looking down on you since you don't know this language, or they're just eager to learn the language.
Yeah, they want to welcome another member into the cult.
Yeah, exactly.
Yeah, but I'm curious, like, do you remember... was there any specific thing that sort of convinced you that this was that F# was a good alternative to C#? Or was it more of a gradual thing?
Um, yeah, I would say it was a gradual thing. I just noticed all the great things along the way. One being the absence of null.
Mm, that's a good one.
Uh, I learned to love immutability, right, as
Mm,
a default. Um, I learned to love expressions, the fact that everything in F sharp is an expression, which in turn opens it up for composability, right? So you can just glue things together in any shape or form. It's quite they when we describe F sharp, we say it's short, and there's this English term. I don't know if you know this,
yeah,
Christopher.
it's concise, maybe.
Yeah, concise, but there's this one term more.
Uh,
It's called.
Dance, maybe expressive.
Let me just. I'll while we're here, I'll just quickly Google it. It's the succinct. That's the.
Succinct. Yeah, yeah,
Yeah, exactly. So for those not familiar with the term, it just means it's very expressive, but in a short way.
yeah,
It was a new term for me as well, so it's yeah.
yeah. You don't have to. Yeah, it's interesting. Like the and you have to think as well. Like the last 10 years or so, it feels like a lot of things have happened in the mainstream languages as well, because like regarding that composability thing, for example, like there are a bunch of imperative coding constructs, like for loops, try catch, etc., that don't compose. Like if you have a for loop and you want to make it do something slightly differently, you have to write another for loop, for example. But I guess nowadays, like most of the higher level languages, they have like built-in support for streams and lambda functions, etc. So I guess what I'm trying to say is that like I think the difference was even more drastic, like I don't know, 10 years ago. Like now it's the landscape has changed quite a bit. There are a bunch of functional programming idioms that have made their way into like C# and Java as well.
Exactly. Yeah, it's well, yeah, it's interesting because one thing I also really like about F sharp, it stays very stable. Uh, I mean, they're very reluctant to introduce just new things, and they don't need to. I mean,
Yeah,
of course, they. I mean, of
it's
course,
perfect already.
yeah, exactly. It could be something coming up that they want to introduce, but in general, my experience with F sharp, it seems to be a very well thought of, well designed language from the scratch. They don't need to, keep bloating up and yeah. So it's a very, in my experience again, it's very simple language.
Yeah, I mean it is a very. I think it is like out of the box, it is a very well designed language. Like you said, like there haven't been that many huge changes as far as I know of, and I think like almost all code is like backwards compatible as well, like or like forwards compatible. I don't know really which term to use here, but like they haven't deprecated any like language constructs as far as I know. You can like run your like 20 or 15-year-old F sharp code without any problems as far as I know. But okay,
And
so that sorry.
yeah, no, sorry, continue, please continue.
No, I just wanted to ask, like, okay, so NRK, that was like how you got into F sharp. But had you done any functional programming prior to that, or?
No. So no, I wouldn't say I have. So it it was kind of the leap, right? Because you have to really quite early on. I just decided that everything I know about C sharp or object oriented way, or like the paradigm itself, I just put that aside and be like, okay, let's just start from scratch.
Okay, let's like go really into like F sharp.
So yeah, I mean, it hurts a lot, right, in your brain. Like, oh my God, like I've spent so many years learning a particular paradigm or language, and then you suddenly have to start from scratch. But
Yeah.
it was well worth the investment because there were times, I learned F sharp and then wrote some F sharp, but then there were times where I had to rewrite C sharp, and I mean, you should be idiomatic to the language and paradigm used, but thinking functionally is beneficial, I would say. So, and that's the way I view it. It's like a toolbox. So, I think there's more to gain instead of just learning. Let's say you know C sharp, and then you just learn Java. That's not much of a. I mean, it's beneficial, of course, but I would say it's more beneficial to jump in the paradigm axis rather than the language axis if you stay on the same paradigm.
Okay, so you're basically saying it's better to learn maybe like some functional language and sort of bring some of those things over rather than learning like, I don't know, going deeper in the down the OOP rabbit hole.
Yeah, I mean, it's I guess a claim from mine I have, but yeah, I would say so. I mean, there's so many. The fact that just learning to write code in a functional, I mean, immutable code by default, right? That's quite different from the way you're used to. You start to think about state. How do you transform state? Why is it good to not mutate state? You think about side effects, like all of these different kind of concepts and terminologies. Like it just opens up an entire new world for you.
So I mean, basically, what you're saying is that like it sort of highlights. Like even though you're still working with the same tools, like in C sharp, it's sort of like being able to think in a functional way, like highlights the, like I guess it makes you a bit more aware of what you're doing, I guess. Like
Yeah.
when I'm like, instead of like thinking, oh, I'm just like, you become aware, like, okay, now I'm mutating this thing, and that potentially opens up like, a bunch of bugs or like error conditions that I wouldn't have otherwise.
Exactly. Yeah, I think that's a good way to put it. So yeah, and I mean in the journey, I maybe forgot to mention, but in the journey of learning all the different things in F sharp, and when you reach the point of using the dreaded word monads and result types, and you start to think about, oh, okay, map, bind. There's a flow of transforming between the types, and it's and once you get the hang of one monad, you start to see a pattern. Like you can use the same kind of pattern across the different types, and that for me was quite eye-opening.
So it's like you can reason about code in a new way, I guess.
Yeah, I mean, you start to notice that there's some default way of solving a problem, and that's kind of the $1 million question, right? We try to solve, and always like, let's all try to follow the same pattern, such that we don't reinvent the wheel. And my experience is that it seems like in functional program there's more like a default, which people tend to follow. I don't know. It's just, I don't know what's your experience, Christopher?
No, I think it's true. And there was a great podcast that I listened to with Gabriela Gonzalez, where she, it wasn't even like a programming podcast, I think. I think it was actually like a math podcast. But she was talking about like something that she called like thinking in algebras, which sort of put the finger on this thing that I had also been thinking about it, but I didn't really have a word for it. And it's like, once, like you said, like once you start to realize, like, okay, this thing is actually like either this type or this thing I want to do. It's like, it's a functor or it's a monad. It's like functional programming gives you like a new. In one way it's a new vocabulary, but it's also a way of formalizing programming constructs. So, because like you said, once you realize, oh, this is a monad, that means that I can do these things with it. And that sort of, I don't know, because I had the exact same experience when I learned F#, actually. Like, you sort of, you start thinking more in terms of like composing operations and data structures rather than like how the program flows, because like I think it's harder to reason about a procedural program in the abstract, because like you said, you can have all these mutations and side effects, etc. But in a pure functional program, it's easier to think of it more like math, like an algebra that has certain guaranteed properties. So I think there's something there, like, it gives you and you can of course apply this principle to like OOP code as well, just like you said. It sort of unlocks a new way of seeing, I think.
Yeah, no, yeah, spot on. It's I mean, as you said, like you're saying, having certain properties. Like, take for instance, when we talk about deterministic and non-deterministic functions, that kind of way of thinking, I never thought about it when I was in the OO world. But suddenly it became important, right? Like, okay, what is the difference between impure and pure code? It has a very formal definition. And if you put that in contrast to, and again, I don't want to sound like bantering or saying stuff about OO, but when you talk about clean code and dirty code, let's use that term, it's kind of a bit too abstract, right? It has. So for me, it's like in F# or in FP function programming, as you said, like you get this new vocabulary and a more formal way of viewing the world. And when you start to think about, okay, you have pure functions, means that you can compose and be safe and sound, that you expect the output to be what it says to be, right?
Yeah. Okay. So yeah, like you said, it's like I guess it's with like the distinction between clean code and like, well, the dirty code. That's more like subjective. Would you say, or?
Yeah, exactly. I mean that's my experience. Again, I'm just talking from my point of view, but yeah. I don't know. I just when you think about, and the funny thing is about, right, you can when you take this concept, for instance, of pure, because when you think about function programming, you also have the spectrum, right, of purely functional, right?
Yeah.
Which is, Haskell, for instance, that's purely functional, but F# is not. But my experience, I feel like it's a nice compromise, like a nice balance between being very pragmatic, but yet again being very formal and precise.
So I mean, just to like make it a bit clear for the listeners, maybe, like what is a pure function? Like what's the deal with that?
So a pure function is a deterministic function, meaning that given input A will always produce the same output. So in contrast, an impure function is a function which has a side effect. That being I/O. So let's say if you have a function which concatenates two strings and then it also does some database lookup or reads to disk, then you have a non-deterministic function, because you have a state outside of your function which can manipulate the outcome of the function.
Okay, so you can get like different results or different things can happen every time you call the function, basically. Like
depending on the moon phase.
yeah,
Yeah, so yeah, and that kind of ties into the whole philosophy of writing software, right? Because we want to make predictable systems. You want to understand and have a feeling that or a sense of feeling that you have control over your system. You know what to expect out of the function. So just to as an example, in our software, which we write at Ren, which is for the electrical transmission modeling, we put or all of our functions in the core domain are pure.
okay, yeah,
So that's, I mean, one thing is composability, then the second thing is testability, right? Because you can test without doing any mocking or, yeah, write small, simple unit tests. And yeah, so that's, I guess that's how I mean, to put it in a different way, in my experience, not the only way, but best way to handle complexity is you have to start local in the small. And in our case, I feel like when we write small, pure functions, you can compose, and then the complexity is somewhat manageable, or at least easier than the way we've done it before.
yeah. I mean, for one, it makes it much easier to test, right?
Yeah.
Okay, so if all of the core functions, so to speak, are pure, how do the side effects like get into the system? Because at some point the program needs to affect the outside world in some way, right?
Exactly. Yeah. So the way we just use this, functional architecture, which is you have a pure core and then an impure layer. So and the way we deal with take for instance errors, right, in your flow, we use the result type. So that's how you introduce some impurity, I guess, into your code. Using the result type does not mean it is impure inherently, but it's a way of handling, as you say, the chaotic, impure outside world.
Yeah. Yeah, but I mean, yeah, the error value, like the error type, it's still like, it's still just a value, like, so it doesn't do anything. Like if the function failed, like the first time you called it, it's gonna fail the second time as well. Like, it will always produce, as long as it's pure, it will still produce the same thing, right? But okay, so where, for example, if you need to call the database, where does that happen? Like all the database calls, etc. That happens like in the outer layer, or how does that work?
So I guess I mean it also depends on the nature of your software, right? Because in some places you have some I/O, do something magical, and then do some I/O again, right? But ideally, I guess it is to let's say your traditional three-tier software, or sorry, architecture is like you have an API coming from the outside chaotic world. You come into into your software, and then you transform to strongly types into your domain, do your business logic, and then you reach the bottom of your software, I guess, or sorry, not the bottom, but the edge, where you do I/O. So you move all the I/O to the edges, and then if you can, again, right, it depends on the software you're writing, but ideally, I think that's the best way to go.
Yeah, so kind of like that. What's it called? Like the pure or functional core imperative shell.
Exactly.
Pattern. Yeah, there's a great presentation by the name escapes me.
Scott Larsen, maybe, or
yeah, or no, it's the Destroy All Software guy. I can link to it in the show notes. But I think he was the one that coined this term, and he also has a very clear. Gary Bernhardt. Yes, that's
okay.
right. He has a very good presentation.
I just want to make a shout out to Scott Larsen. He's he has been a huge influence on me, on everything from his website F Sharp for Fun and Profit, and all the lectures on YouTube. So yeah, just a
Yeah,
shout
he's
out
a
to this
really
guy.
good, he's really good at getting his point across. And I suppose you have read his book as well, like the domain-driven design made functional, or that's the
Exactly.
title, right?
Yeah. So that's I mean, that's, I guess, the first time I read it was, yeah, this was at NRK. It was around the same time I was learning F Sharp, so it was very nice, hand in hand with domain-driven design, but done in a functional way.
Mm.
And using the excellent algebraic type system in F Sharp with domain-driven design, it's hand in hand in my experience.
Yeah, can you tell me a bit more about like what is domain-driven design? Because that's a like a buzzword you see thrown around quite a bit. But I mean, what does it mean in practice?
Well, in practice, I would say maybe the first thing is to clearly define the boundary of your software, and then like what it should do and what it shouldn't do. And then the second thing is to break it down in smaller boundaries inside your context. So I guess you would call this boundary context. So that's the one thing. The second thing is to your software, meaning your source code, I guess, should reflect. I mean, your words, the code you write, you should reflect the real world. So you use the real terminology used by the domain experts. So try not to introduce too many layers of abstraction, and you complicate the domain you're trying to model by the accidental complexity of your technology you're using, right? So the whole essence, when I think, yeah, the concept is called ubiquitous language. So you try to use the exact same language as the domain you're working in. So in our case, it's electrical transmission modeling. So we try really hard to mimic or use the same words as our domain experts.
Okay,
So
yeah.
yeah, so the first thing is boundaries, clear boundaries, like what it should do, what it shouldn't do. The second thing is the language, which is a really big part of it. And the third thing is, I would say, yeah, the typing, explicit typing of everything.
Okay, so everything should have like its own, or yeah, is it that everything should have its own type, or?
Yeah, because I mean, the whole thing about the algebraic type system in F Sharp, it's so cheap to create types that I mean, you could just do it, right? And it will help you along the way. And this ties into my point being of, in order to handle complexity, you need to start small. And if you type out everything, the compiler will help you. And your types will reflect your domain. So just to give an example, when we talk about poles in our system, we tend to talk about the diameter on the top and the bottom.
Oh, so like electric poles?
Yeah, exactly. Yeah, electrical pole, yeah. So you could say, right, that the top and bottom, it's just millimeters, right? It's a length. Or you could just go all the way and type it out and say that the top diameter of a pole is its own type. So you could never end up in a situation where you call a function and you accidentally swap those two because it's strongly typed.
Yeah, that's I mean, that's a common problem, right? When you have this like what is it called, like primitive obsession.
Yeah.
So F Sharp provides a good cure against that, it sounds like.
Exactly, and it's I mean, the types are just so small and easy to create that it comes very natural. And
Yeah.
I guess you can, or I mean, I can understand that people coming from a very dynamic world, that it feels a lot of let's say plumbing work. But my point is, it's worth the effort. It's worth the effort to have more friction in up front, because you have to create the types, you have to put it in, you have to handle it. But it's worth the effort because once your system scales and becomes a lot of thousands of lines of code, you will thank yourself because you put in the effort of the typing of everything.
Yeah, I personally, I think just it makes collaboration much easier, because I mean, I think a common issue when you need to fix someone else's code is like sometimes it's not always easy to. I mean, you sort of have to get into the same mind space as the person, unless you have like a lot of types that help you, because the types sort of like document like what was I thinking when I wrote this. It's sort of like sort of like a blueprint, I guess.
Yeah.
And if you need to fix something repair something in your house, like the foundation, for example, then it's very helpful to have a blueprint that shows you, like, okay, what was the original architect thinking when they built this?
Yeah, exactly. And I think for our case, speaking on your take of blueprint, we type out, you have the type of, product types and sum types and all that, but we also use the type alias. So I guess some languages have this. I guess the equivalent would be in a header file in C++. Is that when we write a function, which is like core part of the domain, we write a type alias. So stating type create user info equals what the input is, and then a line and stating what the output would be. So that kind of, my point is it kind of ties into your take of, the whole idea is to, I guess, to formalize. And one of the best way to formalize your software is through types in my experience.
Yeah. I mean, if you think typing is tedious, I would say that, like, writing documentation is much worse. And
exactly. Yeah.
And then you have to manually make sure that it's also correct. But since you work a lot with, like, lots of like physical measurements, like watts and millimeters, etc., do you use the units of measure feature in the F# type system as well? Because I think that's kind of like a unique thing.
Absolutely, we do. It's an excellent feature of F#. And for those who are not familiar with the concept, is that you can work with units of measure at compile time, and it's so nice because it just reduces a whole lot of typical bugs, right? Like, are you working with millimeters or are you working with meters? And if you deal with a primitive type, let's say a floating number, how would you deduce that just by looking at it? You kind of have to guess, right? But if you use units of measure, it forces the compiler helps you along the way to put the right value in the right place.
Yeah, how does that work? Like, with can you add because I haven't used this very much myself. Like, can you add a unit to like any type, or how does that work?
What do you mean by adding? Yes, I think you can, right? I mean, or
I know you can add, like, you can say that, like, I have if I have an integer, for example, I can give it a unit of measure that says, like, this is a meter, for example.
Yeah.
But can I also add a unit of measure to, like, a string and say that, oh, this is an email address or something like that?
That's a good question. I haven't tried that out, but but I mean, I guess it's a way of tagging the type, but it wouldn't, like, compile wise help you to ensure that it's in email.
Yeah, it's like, I mean, you usually use like I mean, I guess the usual way to create a new type like that would be to create a new, like, what do you call, like a single case discriminating union.
Yeah.
Basically, you wrap the type, like you described with the top and bottom of the pole, right?
Yeah.
But I mean, yeah, units of measure are really cool, and you can sort of like define conversion functions between them as well, right? Or
Yes. Yes, you can. Yeah, you can.
so
It's
you
a
can say
typical,
like,
we have functions where you just have a raw double, and then you have to transform it to something of unit.
yeah, it's very very powerful, but like, it's when you see it in action, it's quite like, it's very lightweight as well. It doesn't it's very low effort, and
Exactly.
I think, yeah, this is sort of the key as well, I guess. Like, I mean, you can do a lot of these things in C# as well. It's just that, like, it's more work, and then people tend not to do it.
Yeah, it's more work, and it's usually things that happen at runtime. But
Yeah,
in
so they
general,
don't.
like,
Yeah, yeah.
yeah, I mean, maybe there is some, I guess, some really strongly typed ways of handling it with units in C#. But my experience in overall in F# is that everything should happen at compile time, like every
Yeah.
single thing. In that, like, just to give you another example, take for instance, handling dependency injection. My experience when I used, you handling dependency injection using containers dependency injection containers in C# is that you wire up your system, you think you did it correctly, you run it, and then it just explodes in your face, right?
Yeah.
Because you forgot to add singleton or add scoped, whatever, at some interface.
Yeah.
But the way we handle in dependency injection in F#, it happens at compile time. So like your system won't compile unless you put the right dependency at the right place. So for that particular, we use a partial application.
Okay. Yeah, can you explain a bit more how that works?
Yeah, so partial application is a concept where you partially apply an argument or an argument in a function. So let's say you have a function called add, where it adds two numbers, right? A and B. So you can create a new function based on the existing function where you say let add 10 equals add 10, meaning you set the first argument of the initial function to 10, but you create a new function based on the existing one. So you partially applied from left to right the argument. So you prepare your function to be executed, right?
Yeah. Okay, so you end up, like, you start with a function that takes two arguments, for example. Then you supply one of them, and then now you have a function of one argument.
Exactly. Yep. And
Okay.
that's a really powerful. I mean, it sounds like at first like a weird idea, and where would that be useful, right? But
How could this possibly be useful?
exactly. But once you you realize you can easily just create new functions. That's like on the fly. But you can also use it in the context of dependency injection.
Okay, so and how does that, like, so the function, like the way you would use DI, otherwise it's like you have or I guess in C# with all the wiring, it's a bit more magical, I guess. But the dependency is another argument to the function. Is that how it works?
Yeah, correct. So typically, the way we would do it is we, as I said previously, when we have a type alias for a function, let's say let's call it type add equals int dash int, and then a new int, meaning 2 arguments, and then returns an int. So let's say you want to, let's say, implement this function. So what you do is you create a function which returns this function, but in the argument list you can have any arguments you want. So let's say in this case you're dependent on a logger, iLogger in this case. So what you end up doing is you have a function called add, you have a logger, but the return type is the type alias or the function. So you're returning a function. But in order this function to be complete to the signature you initially set to be, right, is that you have to apply the logger to your function. So once you do that, you reduce the first argument. So you go from iLogger to int to int to int to int, int, and int.
Yes.
So your implementation uses the iLogger, but you consuming the function, you wouldn't know, right?
Yeah. Okay. So it's like you supply the dependency, and then you get a function like that just looks like I don't know, any old function, but that function actually has now it's aware of the logger dependency.
Yeah. Exactly. And it's a really simple concept, and like as I said, like things won't compile if you don't wire these things up correctly, or these functions correctly.
Yeah. Speaking of Scott Bloshin, I think he had this really interesting article where he compares like various different techniques for dependency injection. I guess you've read that one. Perhaps.
Yeah, that's also a rabbit hole you can go into, right?
Yeah. There's a lot of things that you can.
Yeah. So in my experience, like you can go through this using reader monad and all these kind of things, and just that's perfectly fine, I guess. But in order to just start simple, just use partial application. It works perfectly fine in my experience.
Yeah. I guess that's it. Like, I think you actually you're really onto something here, because I think that's one pitfall that's easy to run into when you enter this sort of like honeymoon phase of functional programming, where you're really excited about all of these new things that you have learned, and you want to apply them all in every project you touch, and that's not always a good idea, I guess.
Yeah, no, it's a really interesting point you're bringing up, because I guess it is important to explore all facets of I guess any domain of what you're working on. But as you say, like in a functional program, you can go quite deep in many places, right? And then you end up maybe romanticizing the idea of using more complicated concepts, which is good in some cases, right? But in some cases, in other cases, you actually just complicating your software unnecessarily, and it becomes, I guess, in some cases, some sport of use this fancy thing here, and So you have to be aware, like, do not, try to keep things simple. Is my take.
Keep it simple.
Yeah.
Silly.
Exactly.
Yeah, no, I think that's a good point. And I mean, this isn't exclusive to functional programming as well. Like, I mean, I think back in the 90s, there was a lot of people who read that, the Gang of Four design patterns book, and then they came back to work the next day, and they rewrote everything to be like factories and like inversion of control things, and like blah, blah, blah. I think it's just like a general thing of like I don't know. Once you see something, once you learn a new technique, you're like, I want to use it. Like, suddenly I have a hammer in my hand, and I go out looking for like things that look like nails.
Yeah. Exactly. So my point is, like, you should be aware of it, right? Like, just it is important to explore and learn new things, but be kind of aware of just not just try to shove everything automatically in, and as you said, like it's a pitfall in
Yeah.
any domain.
Yeah. Do you think there's a way to like, strike a good balance between this? Like, because I mean, if you make things too simple as well, that's not good either, right?
Well, I think speaking from my experience with working with my colleague Øystein Haga, which is he's also F sharp enthusiast like myself. Uh, I guess one of the rules or the culture we've established is like if we struggle to explain the concepts we're trying to introduce, it's like maybe it's a sign that we're trying to do something unnecessarily complicated.
Yeah,
So
that's a good rule of thumb, I guess.
yeah, I mean, and one being like, for instance, part like this way of handling dependency injection. Like if we both understand the partial application, it's just go for it. And if we really see the benefit of introducing a reader monad, like sure, it's we can do that at a later point. But for now, let's just keep it keep it simple.
Yeah, I guess like don't start with the complex solution, I guess is the takeaway here. Like, start simple and see if that works. Then you can like, make it more complex if you have to. But I want to ask you as well, like was Ren, was that like an F sharp organization from the beginning, or did you sort of transition to F sharp?
It was a transition. So the software I work on is called Netlin, and it's a C sharp, primarily C. It started off as a C sharp desktop application, Windows Presentation Foundation, and yeah, C sharp ran for some years, but then the main developer he quit, and then I was there for some time, and then once he quit. I and my nearest leader, he's also an F sharp enthusiast. It was an easy choice for us, at least. But of course, we had to, you have to check with the organization if it's okay to introduce new language. And we got a yes from the top, I guess. And then yeah, it was no problem for introducing F sharp because. The beautiful thing about F sharp is it can coexist with C sharp because you're working in the same that's runtime.
True. It's all .NET under the hood.
And the cool thing about when we started writing F sharp is that we one way of hiring or getting Øystein, my colleague, into our company is actually we said to him, we can guarantee you you can work with F sharp, and there's no internal combats fights you need to take, so knock yourself out. And he was sold quite fast actually on the idea, so we're very thankful to have him on board.
Yeah, that's cool. Yeah, are there any did you face any difficulties when introducing F sharp?
To be honest, I wish I could say we did, but we didn't. And yeah, again, this is Stig, our like the head of Ren. He, I guess, I don't know if it's beneficial that he's an engineer himself. If he kind of views his view on tools is kind of maybe different. I don't know. It's like I try not to categorize and be or generalize, but for him it was like, you have a language where your null is absent, and you believe you can write more correct and precise and more reliable software, and there's not much friction to introduce it. Then I'm all in for it.
Yeah, because I don't know, does it make the job easier that I mean, since you're working with electrical engineering, I guess there's a lot of math involved. Does it help that F sharp is more math-like than C sharp, or doesn't it? Is there no difference?
I wouldn't. No, I wouldn't say. I mean, yeah, F sharp has this, I guess, math like stereotype to it, but I wouldn't say there's any. I mean, the only benefit in that context, I would say, is the units of measure. But
Yeah.
we use F sharp because we love the language and it makes us write software faster and a more reliable manner. Like that's the simple answer to the question.
And I mean, looking back now, like, would you consider that it was like a success to write it then in F sharp? It's a leading question, maybe, but
I would say that we operate in like our velocity of producing things. It's much higher now, much greater. So I would say it's successful in that sense, and successful in that sense that we see fewer bugs, and we can localize errors much faster.
Okay, so if something does go wrong, you can. It's easier to point out, like, okay, this was the source, or
Yeah, exactly, and that kind of ties into using, for instance, the result type, because you formalized your errors in your system, and you think about errors when you use the result type. It's just like you can just naively think about happy path and throw exceptions all over the place, and you actually know, like, okay, this is an expected error state.
Yeah, because like it's a bit scary, I think, sometimes working with like non-functional code, maybe pun intended, but like the fact that a bunch of things can't throw exceptions, which you might think might not think of when you're writing the code. Like, I mean, usually this is well documented if you look at the APIs, but sometimes you're just skimming code and you don't realize, like, there's basically like a stick of dynamite hiding here, because this thing could blow up at any point. But if you have a result type, it's like, it's very clear and explicit.
Yeah, and that ties into the I would say, like, the general philosophy of FP versus OO, is that in FP we tend to be more explicit. Like, it's all about explicit. Like, tell me based on your function signature, like, what is going on. Like, don't do anything implicit things. Implicit in this case would be like throw an exception, right? Because how do you, as a consumer of function, like, okay, you can rely on reading the documentation, but yeah, we developers aren't the like you I mean, okay, that's like the let's say discipline part, but ideally you want your compiler to tell you what is going to happen, or what can potentially be an error state in your system.
Yeah, like you said, we developers, we're not very good at neither reading nor writing documentation, I think. But the type system, it won't lie to you. So
Exactly, it won't lie, and and that's also one thing, like, I noticed when people, like, if you learn F sharp or FP for the first time, like, there's a lot of, I guess there's a lot of friction, feeling that there's a lot of friction, but in my experience, like, it's more about the compiler is actually helping you solve things at compile time, rather than you writing a function fast, hitting run, and then explodes in your face. You have to stop, and like, this feedback loop is much slower, right? But if you actually have a compiler doing this at compile time, it goes much faster.
Yeah, because you get feedback, like, right in the editor as you're typing. I mean, that's it doesn't get much quicker than that, I guess.
And one thing I maybe forgot to mention is typing out things and being more precise and domain-driven design. All that is one of the, I guess, the biggest benefits is that it's easy to refactor your code.
Okay, yeah.
Yeah, because you feel very confident that you're not, at least I do. I mean, you're not breaking the system in a million pieces. Like, okay, if this doesn't compile, there's a reason for that. And then you just solve one problem after another, and then quite often you just feel quite certain that, okay, you hit run, and then it will work. But yeah, it's not perfect, of course, but yeah, I just wanted to mention the refactorability of the
Yeah, and would you say this is because of the type system that sort of
yeah.
keeps everything in check?
Yeah. And yeah, now I'm going a bit back and forth, but going back to, you asked about, introducing F sharp in the company and all that. And my experience is that, you could say, I guess the typical argument is like, if you use C sharp, there's a greater pool of talents, or greater pool of potential talents, right? Which is probably true. So there's greater people to choose from. But then again, you have a greater job of actually, filtering the noise. So in my experience, like if you choose F sharp, and like the counter argument, it would be like, okay, if you choose F sharp, there's fewer people to choose from, right? But my experience is like there's like the few people who actually do F sharp, they're really, I mean, they're good developers.
Yeah,
like that's one thing, and the second thing is the movability of a person going to a company that use F sharp is very, very high. Like, to put it in a different way, it's a sales pitch to any developer. Like if there's a developer who loves F sharp, he's probably ready to quit his job. Like for instance, Øystein Haga did. He was really F sharp enthusiast, and he was like, yeah, I really love this language. I want to work with it full time.
Yeah, because and if it's a C sharp dev, like they can just move to another C sharp company. Whereas if you have like once you get someone on F sharp, they become hooked.
Exactly. So for me, it's like all these recruiters, like it's a hidden gem. Like as a company, if you want to attract talent, like one hidden gem is to actually use a technology which is I wouldn't say esoteric, but take for instance F sharp. Like I would bet that you would find people just ready to drop their current work and be like, yes, I'm all in. Like, sign me up.
Yeah, and then it's like Hotel California. Once they get in, they can never leave.
Nope.
Unless they find another F sharp company. Yeah, and then that's a good point. It's like one weird trick to get better recruitment. But I mean, did you? Because you were like onboarded as an like you went from being a C sharp to an F sharp developer. But have you been part of like onboarding and like more C sharp developers and getting them into F sharp?
Well, yes, I've done some workshops and courses on F sharp. So yeah, I've and both when I was working at a consultant company, I held a course/workshop. Teaching people F sharp. So it's mixed results, right? Some people are open to it, some people are not. So you have to respect that. But I really enjoy teaching F sharp. So it's a good segue to me name dropping my F sharp course.
Oh yes,
fsbitesized.com.
Yes. Yeah, tell me more about that. Like Almir has this course, and I think you have even prepared like a promo code for our listeners.
Correct. It's Func Prog is the one word, Func Prog with a C, and you get a 25% off.
Yeah, much appreciated. So go check out Almir's course. As soon as you finish listening to this, there will be links in the show notes as well, and it's called like FS Bytes. They can go to fsbitesized.com, right?
Yep. Yeah, and also the whole story of the course is I always had this idea like, it would be cool to like while I was learning F sharp, like it would be cool to create a course and spread the word. But more importantly, like one benchmark for me, like in order to actually know or have a feeling that I know something is that you're able to teach it.
Yeah, that's right.
So I use it as a benchmark for myself. Like, okay, if I'm able to create a course and people are willing to pay for it and actually learn something from it, then hopefully I can, say that I'm a good F# developer.
The student has become the teacher.
Yes.
Yeah, but tell me more about this. Like, what's the who is like the intended audience? What kind of prerequisites do you need?
I would say none. You could start. I mean, you could probably argue it would be maybe beneficial to have some dev background, like programming background. That would be ideal. But in theory, you could start from scratch, I guess. So the whole course is based on me giving video lectures, and then you pass some quizzes, and then you have some tasks you can do, and then I also provided a solution. So we start really, taking everything from scratch. So it's been I think I spent like 10 months straight creating this course.
Okay. So you poured a lot of like blood, sweat, and tears into this thing.
Yeah, you could say so.
Yeah.
No, I just got hooked, right? Like I was like, I need to do this, and just bought a domain, created a logo, and then started writing all the things I wanted to talk about, and then just a funny story is like I remember in my previous job when I worked at a company called Resoptima, my boss then Owen, he was a Scala guy.
Oh, okay,
and I also knew that he was a photo video guy, so I was like, maybe I can borrow some lighting from him, like when I was recording myself. And I was like, where did you get this light from? Like, it's really professional. And the funny thing is, he was like, I actually had the same idea about Scala.
Oh, okay.
So he had the same idea about creating a Scala course.
Yeah.
But he got to the point where he bought the gadgets but didn't like execute the
classic,
course.
Classic. Yeah, that's the fun part, right? Getting the gadgets.
Yeah, exactly, and that's a trap. I was like, I'm not gonna buy any gadgets before I do the hard work first.
Yeah, that's probably good idea. Yeah, it's like.
So the course has been really fun, and I've seen it's been used actually in a professional context. I had at a client when I was a consultant. They had some new people coming in using F#, and they actually bought my course.
Okay,
so that was
cool.
Quite fun. And now my latest purchase was some guy in China. So.
Oh, okay, it's spreading.
Yeah.
So
in the course of creating this course, no pun intended, I also I said yes to any opportunity coming my way that was F# related. So there was this book written by Ian Russell called Essential F#.
Okay.
And he asked if someone wanted to read through his book, like. What's the correct English term for it?
Yeah,
it's called.
A test, read, like a beta tester.
I guess. Yeah, exactly. So you read the book and then you look for errors and yeah. So I did so, and that was really fun experience, and yeah, I was kind of proud that I got my name on the book. So everyone should check out the book Essential F#. It's really. It's a really good starter for learning F#.
Yeah, I've heard others recommend that book as well. Like, it seems like a really nice. Maybe you can get both that one and domain-driven design, because they sort of approach the same thing from different angles, right?
Exactly. So and one of the last things, I guess, in regarding F# and opportunities, I got asked to be a external censor for a master degree thesis.
Oh, okay.
Because they used F#, so
used
that was
in
kind
academia.
of fun.
as well.
Yeah. So and I guess the long running joke is like, but F sharp is only used in academia, right? But that's not true. We're using F sharp. So
Yeah. I think like, you know, and if you look like deep enough in academia, people are like, oh, F sharp. I guess that's like one of those industrial type languages, like, you know, not like Haskell or. But like, so did you find any errors in Ian's book or?
Yeah, well, errors. There were some things to adjust, and I helped him out to simplify some concepts. So that was really fun experience. So yeah, it was really fun working with Ian, and like the only that's it kind of ties into a point I want to make is that the F sharp community is very nice. It's very helpful and open, and yeah, that's my experience at least. Is like and when I say community, I mean, you know, either being on Twitter or Mastodon or the fsharp.org or wherever.
Yeah. There's a Discord as well, right?
Yeah.
I think it's like quite active. But yeah, I agree. Like, you know, I think, I mean, it's a very small but welcoming community, and maybe that those things kind of like tie into each other. Like, you know, people are like, oh, one more of us. Like we're
Exactly.
we're
Like,
up to 13 now.
yeah, exactly. That's all. Yeah, that's the long running joke, right? It's like there's only 15 of us.
Yeah.
But I don't know. Like yeah, you made me think of a point. Like because people tend to say that well, C sharp, it's, you know, because a lot of the new features of C sharp, it's like it's a copy, right? It's like a copy of F sharp. For instance, you know, record types, that being one.
Yeah.
And there's been rumors now, I think it's gonna get support for unit types as well.
Okay.
So the argument is like, but why should you spend time and effort of learning F sharp if C sharp is already becoming F sharp-ish? And my main argument, counter argument for that is that like it's not the same thing. It's not like take for instance immutability by default. That would be a breaking change in C sharp. So like C sharp will never ever reach a point. I would say never ever, but yeah, you get my point. Like it will be a breaking change to say that everything is immutable by default. The second thing is everything, as I said initially, everything in F sharp is an expression. That is not true for C sharp. That would also be a breaking change, I believe, if you introduce that as a rule. So yeah, I just wanted to put that out while it was fresh in my mind.
No, but it's a really good point, I think, because that's one objection I've also heard several times. Like, you know, why should I, like, you know, why bother learning F sharp, or why bother doing something else other than C sharp? Like, you know, when C sharp is, you know, they're accruing all of these features eventually. But I agree, it's like, you know, I mean, you still have to deal with all of that baggage, right? I mean, and the same thing with like null, you know, sure, there is like, you know, there's this new annotation where you can say that this value is nullable, for example. But like, you're still gonna have to deal with a bunch of nulls. And I mean, to be fair, this goes for F sharp as well when you interrupt with like C sharp libraries, etc.
Exactly.
But it's that it only ever happens at the boundary, right? I mean, as soon as you transition into F sharp, then it's like an option type. So it's like, you know, you get all that type safe goodness. And like another thing, like, you know, exceptions, you have to deal with those as well. They're not going away.
Yeah.
But you're saying, like, you know, even if you think that all these things are coming to C sharp, it's worth learning F sharp anyway.
100%. Yeah, I would say so, because it's I don't know, like what would be the analogies? Like it's kind of two different cars, I would say. Like yeah, you can add maybe, you know, some certain features to this car, but it won't drive as the other car. and I'm not going to compare any car types, but yeah, I guess the I guess that's the
too like, is it too contentious, like too too controversial?
People can think of their brands in their own minds, but yeah, I mean, it would be analogous to that, I guess. To like it's a different breed, like it's a different type of thing. You're like you learning F sharp and thinking functionally. It's a different way of doing things, and as I said initially, like it's worth the effort of learning the paradigm and learning a new language within that paradigm if you're making that jump, right?
Yeah, like you said, like, you know, there are takeaways beyond just learning the language itself. Like, you know, like just like you said, you can learn a new way of thinking. You can learn a new method of structuring your regular object-oriented code, for example.
Yeah, exactly. And I also want to, like, again, while we're talking about this, like I tend to hear, like, you know, people say, F sharp is not used, it's not used anywhere. But take for instance, like when we moved here to Bergen, I was surprised because I actually held the F sharp meetup at Rennes, and I was surprised how many people came and how many people use F sharp. So you have a company called Infotech, I think they're called, and then you have the Sparbank Invest, like one of the main banks in Bergen. You have Bergen Synergy. So there's a lot of companies. It's just that maybe people aren't that vocal about it, right? Like it's maybe in the niche thing. But my experience, like it is being used. It's not just, maybe it just gets drowned, right? Because there's a lot of other type of content.
Is it also more common in Norway because of NRK, which is a pretty big, you know, it's a pretty big employer?
Exactly. Yeah, it's really big. I can't say for sure, but I believe that NRK is maybe the largest F sharp company by a number of heads, I guess, or number of people in the world. Like I would say top 5. That wouldn't be an understatement.
Yeah, no, I that sounds completely reasonable.
And yeah, you could say that, and it's a good question. Like, why did NRK become this F sharp store?
F sharp shop.
And it's kind of accidental. I think it has to do with the people, right? Like it starts with the people, the enthusiasts. Like take for instance Vagif, which he I think he works now permanently for NRK. He has been a really influential voice in F sharp.
Okay, so he's had a lot of influence.
Yeah, so he drove, and I think a lot of, you know, there was a lot of they were previously working as consultants, but they became started working for NRK, and then they had the flexibility, the room to introduce F sharp without any like there was not any saying externally. They just had the freedom to introduce it. And if I remember correctly, it all started off like it started in the small, right? Like they were like, let's just change the build and deploy script, because it was based on TeamCity. So instead of, you know, configuring TeamCity by clicking mouse and all that, you want things to be configurable by code and all that. Let's just create an fake script, meaning like an F sharp script, FSX. I don't remember if you've ever used that, Christopher.
Yeah, and fake is sort of like the F sharp, like a build system built in F sharp, right?
Exactly. Yeah. So it started off like that. Like, let's just change the build script using F sharp because it's innocent and small. And then the next phase was, let's rewrite the tests in F sharp.
Okay.
And then the last step was, okay, let's write some real, like the source code in F sharp. So, and I think that's how it just got spread, if I remember my history correctly.
Okay. Yeah, so maybe this is a good like playbook if you want to introduce F sharp into your organization. Like, you know, start small.
Yeah, start small. Like see if it sticks, and put it in places where it's safe to explore. And I would say maybe tests are maybe the most safe place because yeah, why would that be? Yeah, I guess you have also better tools as well instead of using fake because I don't know, is fake still being maintained and used?
I don't know. I don't have any, like, you know, I don't know that much about like the F# build systems.
But yeah, either way, yeah, I think you're right. Like start small, like and it could be also, as I said, the case for us, right? Like we took over a C# source repository, but we introduced it in small steps. We had a domain project in F#, and then we consumed the types in C#.
Mm. Yeah, and was there any like issues with the interoperability between C# and F#, or was that just like?
I wouldn't say so. The only time I felt, and maybe there's a fix for this, but I struggle to find it, is that if you're not able to use partially applied functions
Oh yeah, that's
in
true.
C#.
Yeah, it's kind of hard to translate.
Yeah, exactly, because it has to like, I guess, to compile. Yeah, I don't know. Like I've never got that to work. So, and I believe yeah, it's not working today as well.
Okay, but as long as you stay away from that, like, you know, it should be fine.
Yeah, yeah. So it's I wouldn't say it's there's no issues with using F# types in C#.
Cool. Sorry, I just want to ask, like, how are we doing for time? Do you need to run or?
No, I can.
Okay, cool. Yeah, I think I have a few more minutes.
Yeah.
Just because there were some more things on my mind. One more thing I wanted to ask you, do you think there's any domains or any problems where F# is a particularly good fit? And like on the flip side, are there any problems or domains where you think it might not be a good idea to use F#, where you should use maybe C# or something else?
That's a good question. I would say, yeah. I was thinking maybe game development would probably be beneficial to use C# because it's inherently there's a lot of mutation, and you work with a lot of matrices, and I guess you don't want to copy the matrices or the arrays you're working with. So, but you can still do that kind of programming in F#, but it's just maybe it's because I don't know if we mentioned it early, but F# is functional first, but it is multi-paradigm. So you could,
oh, that's true. Yeah.
you could write C# code like C# style OO in F#, but it's more I guess maybe it's more effort, right? So, but going back to your question of like where you could use F#, I would say in any domain. I don't see any in my mind. Maybe I'm like a broken mind by now, but
I've been brainwashed by
exactly,
the F# cult.
exactly. Yeah. So, but I don't differentiate. Like I can't see any places where it would be more beneficial or less. Like for me, C# and F# is like it's the same. Like maybe with the only exception of game development being, or like if you do a lot of heavy matrices.
Yeah, I was as funny you said game though, because I mean that would be like my first the first thing I thought of as well would be like game development, because like I mean I think it might be difficult to make it like really performant and also like be idiomatic in F# because there's so much, like you would generate a lot of garbage, for example, a lot of memory churn when you have this like really fast running simulations. But maybe that isn't true. Like I haven't actually stress tested this, so it might still work. But I guess it's like, you know, someone will have to go and write the game and get back to us.
Yeah, exactly. An experience report.
Exactly. But I mean, getting back to that domain-driven design thing, I think that's one area where F# is really, really good. Like, you know, like mapping out a domain is. I was gonna say it's a pleasure in F#. I'm not sure if mapping out a domain is ever a pleasure, but it works really well with the F# type system, and like the discriminated unions, because like you said, it's so easy to create types. There's basically virtually no overhead. Like you don't need to have separate classes everywhere, etc. And it's like easy to just stuff a lot of different types in a single file.
Yeah, and also the fact that once you, because take for instance unit types, I tried to model that concept in C#, and I always found it like to be awkward and clunky. But in using unit types in F#, it just felt so natural, and the fact that you can just say that a case can be either empty or it can be a type or a function, it's just, there's no I guess you're free to almost do whatever you want, right? And it ties back to what if there's one word to summarize how I feel about F#, it feels so ergonomic. It feels so easy. Like you have a thought you want to formalize by code, and then you can execute it because you have concepts that can help you along the way. And unit types or the algebraic data type system being one of them.
Because it really helps you, I don't know, when you want to design or architect your code, I guess.
Yeah, definitely.
Yeah. Do you have any one issue that I have noticed with F# is sometimes the compiler can be quite slow. Is that something you've had any issues with in your work?
I wouldn't say so, but then again, maybe it depends on the lines of code you reach, or I guess it is probably a function of that. But I know, or I believe that the later versions of F#, they've spent some time on performance of the compiler, if I'm not mistaken.
Yeah.
But in general, I wouldn't say that's a problem.
Yeah, I mean, I think it depends a bit on what you do. Like, if you try to do a lot of crazy type level stuff, and there's and we haven't even talked about the type providers. That's not a cool thing.
That's a magical thing.
Yeah. Can you explain really quick type providers, Almir? What is it?
Yeah, so type provider, you have different kinds. You have, let's say, for instance, JSON type provider. So what you can do is you can take a sample response of a JSON formatted document, and then the compiler can infer the types based on the sample you provided. And I guess my best, because it's kind of my experience with type providers is, some cases it could be hit or miss, right? Because in some cases, for instance, with SQL, you can type in the connection string, but then you rely on that being a safe reliable connection, right?
Yeah, because you have to have it then it has to have a connection to the database in order to generate the type, so it won't.
Yeah, exactly, and that's it's a bit heavy in my experience. So my best experience using JSON type providers or the type providers in general is actually using Swagger, open API, always open API.
Yeah.
Confuse those now.
Yeah, the open API.
Yeah, exactly. And that works really good. That's really, so an example, you just download the contract JSON, you have it local in your repo, and then you have your type provider, and then you have the types magically ready for you.
Yeah, it's really cool. I mean, it works great with XML as well. When you have so instead of having to do a bunch of these XPath transforms or whatever, you can't say like, you know, I have an XML document and here's the XSD or whatever it's called, like, you know, the XML format specification, and like boom, it gets turned, the XML data gets turned into like a record type in F#.
It is magical. Like like the first time you see it, like you can't understand like how is this even possible.
It is kind of, it does feel a bit magical. I mean, there are some caveats that I'm aware of, like, you know, I mean, speaking of compile times, that's one thing that can slow down the compilation if you have a lot of like type providers, etc. But I mean, if you know what you're doing and you, like, you know, don't overuse them, like, you know, it's really good, I think.
I think I would say in general, maybe if you're using a typewriter, try to use like have a local reference for what you're typing up. So instead of as I said, like instead of going to a URL where you actually like, I guess you can do that in a Swagger provider. You can paste in a URL and it fetches the response, and like there's more going on there rather than just downloading the response, put it in locally on your machine, and then you don't have this massive I/O happening.
No, that's good, good point. Like, you know, that's the compilation is one part of your program that you absolutely want to be deterministic, I think.
Yeah, exactly.
I mean, finally, is there anything that you would change about F#, like something that sort of like annoys you, that you would like to, like something you wish would be different?
Yeah, interesting. One thing that's kind of I've noticed is kind of scary at some, like in some cases, is that one of the default functions in, for instance, the list module. Let's say you do head or tail or whatever, it throws an exception by default. But if you do try head, it returns an option. But in my mind, I would have done it the other way around.
Yeah.
So I don't know, like maybe I'm weird, but I don't know. Like that's because I've encountered some of the F# functions throwing an exception, which is kind of surprising. I was like, oh, okay, like I wouldn't expect that, but I don't know. What's your take, Christopher?
No, I agree. Like some of those defaults maybe should be changed, or like, you know, to like sort of highlight that head is like an unsafe function. I haven't actually thought about that very much, but because but that's the case in Haskell as well. Like, you know, if you use the standard library, I think the head function in Haskell, it will also return just an element. So that will crash as well. So I think like compared to other languages, F# is still doing quite good. But yeah, I mean, I have my small nitpicks as well, but like overall, I think it's a very well designed language. I think Don Syme did a great job with this, like especially considering that he had all these constraints, like that it has to work with, like, I mean, it's supposed to work with .NET, for example. Just kind of starting out in a difficult position, but I think they made a very good. Struck a very good balance of like being pragmatism versus purity, and also like the fact that F#, at least to me, feels fairly opinionated. Like one thing that sort of I find intimidating with Scala, for example, is that, like, you know, I mean, you can write it in multiple ways. You can write it this way, you can write it that way. And I don't know, maybe it's just I had some traumatic experiences with Perl back in the day, where you can sort of like, they think it's good that you can do things in multiple ways. I much prefer it when there's like, you know, one clear way to do it.
Yeah, and you're emphasizing a really important point, is that, you know, like we tend to talk about there's new features, there's multiple ways of, like, we try to emphasize on everything that's new and there's multiple ways, but I'm like you. Like I prefer the constraints. Like it leaves, like there's less. I guess there's less errors, right, or less ways of messing things up because you have fewer options to actually do it. So I'm also in the camp, as you say, like constraints are good. They're not inherently bad, like maybe as you instinctively or like we instinctively think about, right?
Yeah. No, I think it's great for like collaboration as well. Like when you have a code base or like an ecosystem where people sort of agree on like, this is the way you should solve a given problem. Because, then you, when you crack open a like new code base, you're like, oh, okay, I can understand this. It's not like, oh, wait, someone... I'm trying to read this. I'm trying to read this book, and someone invented a completely new language.
Yeah, and then that's exactly my experience as well, because I work with F# now at NRK, at Resoptima, and now I do at Ren. And what I see, like as you said, like there seems to be like a default. Like everyone seems to tend towards like this default way of doing things.
No, and I think that's really, really good. Like, I mean, you can do like some like, I mean, you can write F# as if it was Haskell, for example. Like you can do a lot of like things with statically resolved type parameters, etc. Like to sort of emulate type classes, etc. But you will not have a good time doing that, I think.
No, it's better to not.
Walk the golden path. Don't stray off the golden path. Okay. Yes, but finally, if people want to, do you have any more tips for learning resources? You have your course and the Essential F# book and the domain-driven design book. Any other good resources for people who want to learn?
As I mentioned, Scott Larsen.
Yes.
His talks on YouTube are really, really good. He has this. I guess he used the analogy of building Lego.
Okay.
Which is kind of really nice because as a child, I guess most of us have played with Lego, so you kind of understand the analogy he's putting forward. So I would say, definitely Scott Larsen, his talks on YouTube, and then also his book. His website, F# for Fun and Profit.
F# for Fun and Profit, yeah. I think Mark. Have you read Mark Seaman's material? Like he has a bunch of like blog posts about like comparing Haskell, F#, and not really F#, but Haskell and C#. I think you can sort of think he writes a bit of F# as well, but you can sort of extrapolate a lot of interesting things from that, I think.
Yeah, I've seen a couple of his blogs because I guess he writes a lot of about FP concepts, so it translates quite nice to F#. And that's in general, like that's also a thing in FP. Like I guess like once you learn map and bind and like how to use a monad, like me switching to Haskell or Scala, like it would be really easy, like because it's formalized in the same way.
Yeah. I mean, like you said, it's these are mathematical concepts. Like they're not like specific to any programming language or to any like programming paradigm for that matter. Like, I mean, they appear in functional programming a lot, but I mean, they're not strictly bound or like beheld to that either. Yeah, and finally, where can people find you, Almir, if they want to get in touch?
So on Twitter, at Almir Mesic, or on LinkedIn, I guess. Where are the places? Yeah, I'm not sure I'm just gonna put my email address out in the public, but you can try looking me up on Twitter or on LinkedIn, I guess.
Yeah, the email address might be a bit too risky. And don't forget the FS bite-sized course, like I said,
Yep.
the links and the promo code will be in the show notes as well. And well, thanks a lot for coming on the podcast, Almir. It's been a pleasure.
Thank you, Christopher. It's been a really, really pleasureful talk.
Yes. Yeah, maybe I'll see you at the next Lambda Days in Krakow.
Hopefully.
Yes. Yeah. Bye.